Everybody, it's Tyler here at the Northeast Wisconsin Signature event, checking in 3565X Xtronomy coming in out of Ontario. Had a good performance so far this year. Skills, Innovate, and Amaze. And congratulations on those awards so far. And so far, Xtronomy doing quite well here. We'll be talking about more on the robot as we go through. Short and Lady Brown, so we'll be diving more into that. Talking about the pneumatic systems and kind of giving you just a full overview of this robot. Also doing some great weight-saving measures on their intake as well, so pay attention to that. Let's learn more about this team coming up here on Pits and Parts. Alice, let's start talking about your drivetrain. What did you choose to go with overall, and talk to me more about it?
For this season, we realized that the average robot spend has been increased. So our main goal for the drivetrain to find a good balance between easy to control and competitive during the match. So for the final, we decided to do a 6-motor 400 RPM on a 3.25-inch wheel. For now, we found this really constant. It's not too fast to control, but provides a competitive speed during the match.
Yeah, your team has been very reliable for a drivetrain overall on that. So let's go over to Lucas, who's going to talk more about the intake and then the Lady Brown mech. You're using a short and Lady Brown. Love to hear more about that, but doing some great cost-saving or weight-saving measures on that intake as well. Talk to me more about it.
So our intake, it's very different from other teams here. We use a polycarb intake with hybrid using a C channel. So the reason we switched to polycarb is because we found that polycarb is way lighter than C channel. So the C channel we remove can balance out our rush claw. And so our intake, we have 2 pre-rollers. So the first pre-roller, we'll bring the ring in, and then the second small pre-roller, it would help assist in bringing the ring in correctly without it getting stuck. And our whole intake uses an 11-watt motor, and we geared it really well here.
I want to ask you on this. I noticed on here with these the polycarb kind of guides here, the way that the bolt is going up. Can you just talk to me more about this design? That's pretty unique that I haven't seen from other teams.
So for this, it prevents it from flying out or like moving way too much. So it wouldn't break and it would keep it in place.
So it's acting as like a hard stop for you, essentially that?
Yeah.
Now, I noticed when you're moving your intake, you do have a little bit of compliance on it as it goes through. Has that affected your match play at all?
No, not really.
Very cool. Let's keep it. Can we see a ring actually come in and showcase what that looks like? And then we'll talk more about your Lady Brown mech as well.
And so it goes in really well, and it goes along really well with our clamp, which we custom built as well.
Very cool. I know you have the color sorter off right now. We'll be talking more about that a little bit later. So we saw that very smooth, as you said as well. Talking about on your short and Lady Brown, how did you have to modify it to get it to fit in your constraints?
So our short Lady Brown, our first robot, we had a longer one, which we couldn't score on a line stake without breaking the expansion limit. But with our short arm, we found out that we can score with score a ring on the line stake, which is really useful during autons, especially for signature event solo AWPs. And, so we also use a ring pusher, which helps the ring go up higher while it's getting scored. Because a short arm, it might not always be in the correct position. It might not always be in the correct position for scoring. So it would score. It would score, and we can keep another ring in. So when we bring it up, the wall stake pusher keeps it in place without falling out or breaking. And it really helps us during scoring wall stakes.
Yeah, we've seen a lot of issues with Lady Browns, right, with them coming out pretty easily on there. So great design to have for that. Tom, talk to me about some of the different programming aspects of it. We see the odometry pods, but I think one of the cool things is it being tied to your hang as well too. So talk to me about how that all comes together.
Well, of course. So for these reasons, we realized that if you don't have a well-demonstrated tracking wheels, we will be now able to play the autonomous period well. So we're playing a lot of times on the tracking wheels part. We have an x-axis and a y-axis to independently tracking the robots axes on the field. One of the pretty unique points that we do compared to the other team is we have 2 sizes fixed for each of the tracking wheels. We have one on the y-axis and one on the x-axis. So the reason we do that is we realize that when the tracking wheel is being fixed by the 2 sides, it's going to be more reliable and more easy to fix. It's not going to be like easy to like shake and getting around the directions. And saying is so pretty unique parts on here, as we use the polycarbonate. So like compared to other teams, they really sometimes they use the steels or the aluminum. We found that's pretty light. We add one of these L channels on there to make them fix. It's not gonna shake. And for overall, we're saying this tracking wheel goes pretty well, and it goes pretty smooth like this.
And how does that lift up? How's it all tied together?
So for now, we realize that the tier 1 hang is gonna bring you like 3 more point advantage during the matches. And for now that we're having issues on that. Before our previous generations robots, we realized our hang is within the lead round, its connections. How about that? We realized that when your robot is doing the autonomous scale, when you're trying to do the wall stakes with your Lady Brown, the tracking wheel is gonna raise up. That do gives a little bit troubles in the programming. So for now, we have our independently hang with 2 pneumatics. So it's gonna raise up, and this have some cutted zip ties with this wires up there. It's connected to each of their tracking wheels. So you can take there when we rise or hang, both of the tracking wheel is gonna raise up and it's gonna touch the ground. And it's also gonna have the conflicts when we're doing the scale program.
And can you talk about how some of your other pneumatic systems come together in your robot?
Sure. So there are 7 pneumatics going for robots with a 1 tank on there. So one help us with our intake raise up. There's like a 1 ring cup that's under about the alliance wall stakes with our your alliance size color rings and up there. So this is help us to deal with that. We have 2 there with the doinker, or we call like the mogul steers with theirs. There's 1 for the catcher and 1 for the doinker for steer up. And there's like 2 of our hook with 2 pneumatics with a hook to help us to catch it up. We believe that's pretty strong now. The other team is pretty hard to steal them from them. And there's 2 more pneumatics on top of there for hang that we just talked about.
A couple last things I want to talk about on this. Mentioned before, you didn't have your color shorter on, but you do have it on now. Can we demonstrate what that looks like? Let's do that first, actually.
Sure. So for our program, we use 3 sensors to help us to getting the color sorting works. There are 2 distance sensors and 1 visual sensors on it. So the two visual sensors, the mainly job of them is to detect the root of the rings to make sure where is the place on the conveyor right now. And there are 1 visual sensors. So the color set is in our programs. Before that, we're gonna pick our lines, and the program's gonna know which colors we are and which color we don't want. After that, when we pick the alliance, and then we go to the matches, we clamp it on. The distance sensor is gonna work up with the whole things. And when the visual sensor detects the colors that we don't want, the convoy is gonna immediately stop and split the incorrect rings in. So for example, for now, we are picking the red alliance, and the convoy is going to split the blue alliance out.
Very cool as it goes through. I mean, obviously been working out great for your team and very effective as it goes through. Last thing here, we were talking earlier that you have an Anton selector on your controller as well too.
Sure.
Why don't you show us a little bit more how that works?
So, different with the other teams, they have a pretty lot of sets of the programs up there. There are only 1 main programs for robots being set. For 1 main programs in there, we have several buttons to help us to figure out what alliance and the programs we want to do. We have a Y button and an X button for alliance selections. We have the Y for the red alliance, X for the blue alliance. When we figure that out, we get in and we have our Auton selections. We have on here, we have our several Auton here. We make sure one we want to do, we press the button A to ensure that. And also during this position, if the several move cause the robot's coordinates getting wrong, we also have this B for the reset buttons. It's gonna reset the whole coordinates of the bot, and after that, when everything goes well, we're gonna click the button A, We plug in this competition switch and we just wait.
So Xtronomy, overall, a great package you put together here. Thanks for detailing more of your robot for us. A lot of great things teams can learn. Of course, wish you best of luck here at this Signature event and throughout the rest of your season as well. Thanks a lot.
Thank you.